Hi everyone, so today we will talk about the intersection of a line and a curve, right? So take note that there are three possible scenarios that we're gonna have if we are talking about the intersection of a line and a curve, and those are, right? So first one is that the line cuts the curve at two distinct points, so take note of the term that we used here. So obviously there are two possible points of intersection. And if you only have one point of intersection, then that means this particular line is actually tangent to the curve. All right. And then lastly, if there is no point of intersection at all, then that means the line does not intersect the curve. You have to remember that when we are looking for a particular value to determine whether the line cuts the curve at 2 points, tangent to the line, or no point of intersection at all, we're going to use your substitution method. Okay, and whenever we substitute a line into a quadratic equation, the end product is also a quadratic equation. And remember that to solve quadratic equations, we are actually using your quadratic formula. Okay, so remember this. And from here, we're gonna make use of your discriminant. This is the discriminant. And this discriminant will determine whether you have 2 points of intersection, okay? Either you have 2 points of intersection, you have 1 point of intersection, that means the discriminant will be equal to 0. And if, of course, the discriminant is negative, when this is negative, okay, remember that when you take the square root of a negative, the answer is undefined, okay? So that means if the discriminant is 0, then you have no real roots, or in other words, you have no points of intersection. All right, so let's have examples for these cases. So have a look at the questions, past year questions, okay, from IGCSE examination, 0606 papers. So first one is that find the values of K for which the line is tangent to the curve. Okay, so take note that your key word here is tangent. So when we talk about tangent, then that means we are only referring to 1 point of intersection, right? So that means just make use your substitution method. So in other words, because y is equal to k minus 6x, that means k minus 6x will be equal to x bracket 2x plus k. All right, and so therefore, using your algebraic manipulation, this gives us 2x squared plus kx. And this can be simplified as 2x squared plus kx. Transfer everything on the right side of your equation so that we can make this equal to 0. So, oh, sorry, this is a k. So therefore, that will give us plus 6x minus k is equal to 0, right? And so that means this is 2x squared plus, we can factorize your x, so that gives us k plus 6, x minus k is equal to 0. And since we are looking or we're referring at 1 point only, then that means the discriminant, which is b squared minus 4ac, must be equal to 0. Okay, so that you only have 1 point of intersection. And in this case, your b is the coefficient of x, which is x plus 6 squared, okay, minus 4 times your a is 2, and your c is negative of k, right? And this will give us 0. So therefore, how much is this? This is a k squared plus 12k plus 36, okay, and this is plus 8k is equal to 0. So it can be simplified as 20k plus 36 will be equal to 0. All right, so this can be factored as k plus 2 times k plus 18, correct? It's equal to 0. So therefore, the values of k are -2 and -18. So these will be the values of k for your linear equation, such that this linear equation will be tangent to the curve, to this particular curve, right? All right, so let's have this particular question. So you have to find the values of k such that the line with this equation and the curve will meet at 2 distinct points. So this is your keyword, okay? These are your keywords actually. So that means if we use the same method, we have to use your substitution. So that will give us 2x minus 5 is equal to x squared plus kx plus 11. And transfer all of these to the right side of your equation. And that will give us x squared plus kx. 2x transferred to the right will become minus 2x plus 11 plus 5 is equal to 0. So therefore, we can have your quadratic equation as k minus 2 bracket x, factorize the common factor, plus 16 is equal to 0. And since we're looking at 2 distinct points, that means our discriminant, which is b squared minus 4ac, must be greater than 0. So by substitution, our b is k minus 2 squared minus 4 times. Your a is 1, your c is 16 is greater than 0. Simplify, that will give us k squared minus 4k plus 4, and then this is minus 64 is greater than 0. In other words, this can be simplified as a quadratic inequality, and it will become k squared minus 4k minus 60 is bigger than 0. And remember from, I think, chapter 1, okay, we were able to solve quadratic inequalities. So in this case, we just need to factorize it first to find the roots of your inequality. And those are k minus 10 bracket k plus 6, right? So therefore, your roots are 10 and -6. And we're gonna graph that. So you have -6 as your value of k here, -6, and the other one is 10. Okay, so I have -6 and I have +10. That means your quadratic function is going to pass through at -6 and at +10. And since, look at this again, the value of your a is +1, and positive means opening upward. So your graph is going to be opening up, right? And you have to remember that what we want is something that is greater than 0. So that means everything below the x-axis, okay, will be negative, and everything above the x-axis will be positive. So that means we are referring to this region right here. So therefore, the set of values of k will be less than -6. So k is less than -6, or k must be greater than 10. So these are the values of k in which your line is going to cut the curve at 2 distinct points. All right. And for the last question, let's say we have this, and take note that this time it says never meet the problem. And if you encounter this particular statement, that means there is no point of intersection. So therefore, same process, since y is x plus c, we substitute it here. So that will give us x plus c is equal to 2x squared minus 3x minus 7. So therefore, that's 2x squared minus 3x. Transfer this positive x becomes minus x minus 7 minus c, right? And so that is 2x squared minus 4x minus, I'm gonna factorize the negative, 7 plus c, okay, is equal to 0. So therefore, since we say never meet, that means your discriminant, which is b squared minus 4ac, must be less than 0. So again, you are dealing with a quadratic inequality. So therefore, your b is just negative 4. We're going to square that. Minus 4 times your a is positive 2. Your c is negative of the bracket 7 plus c, okay, is less than 0. Simplify, this gives us 16, and this gives us negative times negative becomes positive. So this is 8, 4 times 2 is 8, 8 times 7 is 56, plus 8c, right, is less than 0. So 16 plus 56 is 72, plus 8c is less than 0. Therefore, 8c is less than negative 72. That means your c is less than negative 9, right? Divide the whole thing by 8. So therefore, this is the value of your c, or if you're going to write it as an interval form, that means from negative infinity until negative 9, exclusive.